Lesson 10.2. We are still graphing quadratic functions. We graphed simple quadratic functions in the last lesson, and now they just get a little bit more complex. You've just got an extra term in here. So, nothing you can't handle, just some things that you need to know. So let's move it down here. Come on, honey. All right, properties of the graph of a quadratic function. So, just like you knew before, if it's greater than 0, so a, the number in front of the x squared, it's going to open up. If it is a negative, it will go down. The bigger the number is here, the more narrow the parabola. If it is a fraction, say like 1/2, 1/8, something like that, it's going to end up being a wide parabola. It just means it happens slower. Here's the part we need to know. We've got a new formula. Every one before has always been on the y-axis. Well, now they have kind of shifted off and moved off, either to the left, right, up, or down. So you need to commit this little jewel to memory. And that is the formula for finding the axis of symmetry for a parabola. So here's what happens. We've got ax squared plus bx plus c. So you would take your a value, your b value, and have minus b over 2a. So let's just use it right here with this one. Minus b, which is 12, over 2, that's going to be there every time, 2 times a. A happens to be a negative 2. So minus 12 over negative 4, it's a 12. So you've got a negative 12 divided by a negative 4 is a positive 3. So my axis of symmetry is on 3. So I could come right there and put that axis of symmetry on 3. Now, what do you do with that? Because that just tells you how far over, but it does not tell you, this vertex does not tell you how far up or down it is. Well, you can use this. You can use your x value that you got for 3. And if you substitute that back into your original parabola right here, you will find the corresponding y value. So if I put in a 3 here, and if I put in a 3 here, then what I've got is 3 squared, which is 9. 9 times negative 2 is negative 18. Plus 12 times 3 is 36. Minus 7. So negative 18 plus 36 is positive 18. Positive 18 minus 7 is 11. So that means that my y value, my y-intercept, is 11. So I now have my 2 points. I have my x, which is 3, my y value being 11. Okay? So first find the axis of symmetry using your newfound friend right here. Axis of symmetry. Once you find your axis of symmetry and you can find your x value, plug it into your function and get your corresponding y value. So let's try. Let's see what we can come up with. Okay. Next page. All right, here's one right here. We're going to graph this one. So I'm going to go ahead and switch over to a graph. Let me get off of this and go back to this, which, yeah, we're going to be coming up to all that here in just a second. And let me delete that line. All right, we're good to go. Okay, so if my function is y equals 3x squared minus 6x plus 2. Y equals 3x squared minus 6x plus 2. First need to find the axis of symmetry. So my formula, negative b over 2a. Here's my b. So minus 6 over 2 times a, which is 3. So minus 6 is a positive 6 over 6 1. So my vertex, I know at least the x value is 1. So now if I plug 1 in right here, so I've got 3 times 1 squared minus 6 times 1 plus 2. So that will be 1 squared, which is 1, times 3, which is 3. 3 minus 6, negative 3, plus 2, negative 1. So that just tells me right there that my vertex, my line of symmetry, let me draw that line of symmetry first, we found just a second ago. My line of symmetry is on 1. I've got an extra one there, but we're just going to ignore that little baby just for a minute. So I've got a negative 1. So 1, negative 1. Here's my vertex. Now, what do you do with that? Well, you can graph it. And if you graph it and you know that this is like the reflecting line, to be honest, why wouldn't you just graph half of it and then reflect it onto the other side if you know that this will cut it directly in half? So now we don't have to do a big 5-term box. How about we just do one that has 2 in it? Let's say, and I would make them both on the same side. Why would you want one on either side when you can just get the other one from these anyway? So let's just try like 2 and 3. So if I put in a 2, 2 squared is 4 times 3, 12, minus 6 times 2, 12, plus 2. So I got 12 minus 12, plus 2. What about a 3? If I put in a 3, 3 squared, 9 times 3, 27, minus 6 times 3, which is 18, plus 2. 27 minus 18 is 9. 9 plus 2, 11. So 2, 2, 3, now I go all the way up here to 11. So I've got kind of a pretty good look of what my parabola is going to look like. Okay? So if I know that this is my line of symmetry, I can just reflect it. So for my first point right here, if it is 1 away, then I know it's going to be 1 away here. All the way up here. If it's 2 away here, then it's going to be 2 away here. And then without even plotting points on this second side, I can get what my parabola looks like. Okay? Let's try one more. Let's look at the guided practice. So let me get over here and try and erase these lines here just for a second. There's that one. And that one. Oh, look at that. Looks like I had like 4 of them. This thing went line crazy. All right. Now we should be good to go. So let's try the one more guided practice there. So y equals x squared minus 2x minus 3. Y equals x squared minus 2x minus 3. First thing we're going to do is find our line of symmetry. Negative b over 2a. So my a is a 1. So 2 times 1. Negative b, so negative, negative 2. So I've got a positive 2 divided by 2. So my x is 1. So the first part of that is 1. I know that I can go ahead and put my line of symmetry on 1. And know they won't always be 1. And I know that the last example I did was a 1. Just happened to work out that way. That line worked out much better. All right, so now that I got that, I can take my x value, substitute it back in here. 1 squared times 1, 1. Minus 2 times 1, 2. Minus 3. So 1 minus 2 is negative 1. Negative 1 minus 3, negative 4. So 1, negative 4, vertex. 1 minus 4, vertex. Now that I have that and I have my line of symmetry, I can make my little baby chart. Unless you just want to graph 5 points. And if you do, knock yourself out. I would prefer not to. This time, maybe let's try some over here. Maybe let's try 0 and negative 2. 0, negative 2. If I put in a 0 here, of course 0 squared is 0 times 1, still 0. Minus 2 times 0, oh, 0. So I've got a negative 3. And if I plug in a negative 2, it would be 1 times negative 2 squared minus 2 times negative 2 minus 3. This, I'm just plugging it into my equation right there. So I've got negative 2 squared is 4. 4 times 1, 4. Minus 2 times minus 2 is positive 4. Minus 3. So that would be 8 minus 3, 5. Okay, so if I've got 0, negative 3, and if I've got negative 2, 5, gives you a pretty good picture there of kind of what our parabola is going to look like. So if I know that this is 1 unit away, 1 unit away. This one, because I'm just reflecting it, it's 1, 2, 3. So 1, 2, 3 units away from this line means 1, 2, 3 units away from this line. So that's my parabola. Looks a little wavy in there, but it's close. That's what I would say to you. All right, so other than that, we've just got minimum and maximum values. Here's the difference between minimum and maximum. You've got a minimum right here. This parabola is going to keep going up, and it will never get any lower than this. So this is known as a minimum value. If you had a parabola that looked like this, it's going to keep getting lower and never get any higher. This is going to be a maximum. So your vertex would be as a maximum. Now, when they want minimum and maximum, they are only concerned with where it is on the y-axis. Okay? So the minimum of this function right here is the y-coordinate, which is negative 4. If my parabola looked like this, this would be a maximum value, and it would have a maximum value, even though this is, what is that, negative 5, 8. And if it said, what is the maximum value, they are looking for the y value. Okay, so the maximum value would be 8. This minimum value would be negative 4. That's what they're looking for. Okay? So, good luck with those. Again, it's just a little baby steps on top of what we've already done, but I think you'll be fine.